we're going to start with. And conditional probability, there was, I think it was the last one, 27 gives you like a formula for figuring out conditional probability. But conditional probability means that events are not equally likely. And what I mean by that is, you're going to see in the next problem that the probability of Charlie having a baseball game depends on a condition. The probability changes based on a condition. Okay, and so I'm going to say that conditional probability means that, or the probability of events changes based on a previous condition. And I would like to teach this as using kind of almost like a tree diagram to do this, okay? So let's take this example. If it rains tomorrow, there is a 40% chance Charlie will have a baseball game. So this is one of the conditions. If it doesn't rain, there's a 90% chance that he will have a baseball game. And so when I'm coming up with all the possible outcomes, I have to figure out the probability of two things actually and put them together. Rain in a baseball game and no rain in a baseball game. Okay, and so to do that, that's where I'm going to organize it kind of using a diagram. Then it tells you one other piece of information. Tomorrow there is a 20% chance of rain. Okay. My question is, find the probability that Charlie plays his game. So what I'm going to start with is the first condition, and the condition that we're basing this on is if it rains or not. Agreed? So I'm going to put like a little, I guess, bubble over here for rain. What's the probability it's going to rain? So 0.2, right? Which would imply that the probability for no rain is what? Good. And I want to point out to you that 0.2 plus 0.8 adds up to 100%, right? Okay. So then what we're going to do is we are going to figure out what happens based on the rain. So if it rains, there is a possibility that Charlie plays the game, and there's a possibility he doesn't. Okay? And so I'm going to write game, no game from that. Okay, it says if it rains tomorrow, there's a 40% chance Charlie will still have the baseball game. So if I wanted to figure out the probability of rain in a game, I would have to use the multiplication counting principle because we have two things going on. So 0.2 times 0.4. I'll use a little time. All right. What does that give you? 0.2 times 0.4. .08. What this represents is the probability that tomorrow there is going to be rain and Charlie plays the game. That's what we just figured out. Then the probability we can assume, if it's a 40% chance of, if it's raining, there's a 40% chance that he plays the game. What's the chance that he doesn't play the game if it rains? 60. Okay. So then I'm going to do rain and no game should be 0.2 times 0.6, which gives us what? 0.12. Okay, now I'm going to pause right here because I want to point out to you that 0.08 and 0.12 add up to be 0.2, correct? And they need to be because this is a total of 0.2 here. All right, let's do the other one. So if it doesn't rain, there's a 90% chance Charlie will have the baseball game. So I'm going to do no rain and the same deal. I'm going to do game and no game if I can fit it in here. Game. Alright, what am I going to multiply together to get this one? No rain in a game would be 0.8 times 0.9, which is 0.72, right? And then there's only a 10% chance that there would be no gain. So no rain, it sounds like no pain, no gain, kind of. If you switch the M and the N around, it would be. Alright, 0.8 times 0.1 is 0.08. And once again, 0.72 and 0.08 add up to the 0.8 here. If you add these four up, the four different possibilities, they also add up to 1. We talked about how yesterday and the day before that a probability distribution has to add up to 1. So what do you think? To answer my question, find the probability Charlie plays his game, what do I have to do then? There are two ways that can happen, right? That way and that way. So putting them together, what do I get? Nope. Right, because there are two ways that it's not like two games. It's just this is one way of doing it, and that's I have to put them together. The two different scenarios together is 0.02 plus 0.72 or 0.08, sorry, plus 0.72. 0.8. Now it just is a coincidence that it equals that. It's only because those two happen to. Alrighty. So there's a little bit of conditional probability, and I think it makes most sense to use a diagram to do the ones that we're going to do. So then let's talk a little bit about binomial probability. Okay, and so binomial probability actually comes from, once again, combinations or binomial expansion. Okay. So there's some characteristics here about binomial probability that are different than other things. First of all, there are only two possibilities. Okay, so for instance, we wouldn't use this when rolling a dice because how many possibilities are there on that? 6. Okay. This would mean, like we're going to use Miguel Cabrera's batting average in a little bit. Or his one from last year. But this would mean Miguel Cabrera steps up to the plate, hit, no hit. Two possibilities, right? Now I know there's other possibilities within there, but hit or no hit. Or you go to shoot a free throw. You either make it or you miss it. Okay? So there are only two possible outcomes here. A coin. So let's do some notation a minute. We're going to let n, when I use n today, n is how many trials there are. We're going to let p be the probability of a success. Now, sometimes I use that word by a success. It's not necessarily a success. It's the thing we're measuring. Like if we're measuring illness, like what's the percentage that they're going to get the illness, I wouldn't consider getting that illness a success, but it's what I'm counting, okay? So the P is going to represent what probability am I trying to figure out. Well, if there's only two options, we're going to use the letter Q to represent the probability of then no success or not a success, or the probability of failure. And to figure out Q, it's always going to be 1 minus P, because if there's only 2 possibilities and they have to add up 1, I can find it in that way. Okay? So if I said to you, you're an 80% free throw shooter, and I'm going to ask about probability of you making something, the P would be the probability you would make the shot, the free throw. 0.8, the probability you wouldn't make the shot would then have to be 0.2, because there's only 2 outcomes. Okay, so when I'm doing this, then what happens with the probabilities is that I'm going to talk about why we use combinations with it in a second. If I am in this column, and I might run out of room, so I might have to add, to count the number of successes of n trials, if I said n trials and n successes, there's only one way that can happen if they make